This is problem number 12 from section 5.2. In this problem it says use the tables to evaluate f of g inverse of 2. So let's first write f of g inverse of 2, and I want to write this into like terms that are a little bit better. So this is really f of g inverse of 2. So they're saying take 2, plug it into the inverse of g. Well, they don't give us the inverse of g. They give us f of x and they give us g of x. But what do we know about the inverse? So inverse functions are the opposite domain and range from the original function. So this is what we know about inverse functions. That if I have a function, an original function that outputs a 2, well, that output of 2 is actually the input for the inverse function. And the input for the original function is the output for the inverse function. So when we're looking at this x and g of x, for the g of x function, this row is the inputs. But for the inverse has this swapped. So the inverse's input is actually the g of x spot. So when I see g inverse of 2, it's really saying go to the g of x spot, look at 2, which is our input, and look at what the output would be for the inverse. Well, the output for the inverse is going to be what the input was for the g function, which is the 3. So g inverse of 2, I'm just going to write this here, g inverse of 2 is 3 based on this piece right here. That this is the inverse's input and this is the inverse's output. Because they swap, right? This is the g of x function. They swap inputs and outputs. So we end up with f of 3 then when we evaluate g inverse of 2. So what is f of 3? Well, this we can just do straight away. We go to the input of 3, and that's 4. And so our solution for f of g inverse of 2 is 4. And all we got to know is that the inverse functions are opposite domain and range.